A lightning bolt heats the air to 50,000 degrees. That's 5 times hotter than the surface of the sun. Yet the same explosion can sound like a whip crack close by or a soft rolling sigh far away. One flash, 2 completely different sounds. Why? When lightning strikes, it rips the air apart in an instant. The channel of air expands faster than sound itself. That violent push creates a shock wave, and that shock wave is thunder. Stand close, within a few hundred meters, and you hear it raw. A sharp, sudden crack. Almost a snap, like a branch breaking beside your ear. The sound arrives whole, before the air has time to soften it. But move a few kilometers away, and something changes. The crack becomes a rumble. Low, round, and long, like distant furniture being dragged across a wooden floor. Same bolt. Same energy. So why does distance turn a snap into a sigh? The answer begins with the shape of the lightning itself. A bolt is not a single point. It is a jagged channel, sometimes several kilometers long, twisting through the sky. Every part of that channel makes its own thunder at the same moment. But sound travels slowly. Every part of the bolt is a different distance from your ears. So the sound from the near end reaches you first. The sound from the far end arrives later. What was one instant becomes a spread of arrivals lasting many seconds. Stand close to the strike, and the whole channel is roughly the same distance from you. All the sound arrives together. That's the crack. Stand far away, and the near and far ends of the bolt differ by kilometers of travel time. The single explosion smears into a long, rolling grumble. Same event stretched across time. But that alone doesn't make it softer or rounder. The air itself does something to the sound as it travels. And this is the part most people never notice. High sounds and low sounds do not travel the same way. High-pitched sound, the sharp part of the crack, loses energy quickly. It gets absorbed by the air, molecule by molecule. Low-pitched sound, the deep rumble, travels much farther before it fades. So over kilometers, the air strips away the treble and leaves only the bass. Think of a neighbor's music through a wall. You hear the thump of the beat, never the singer's crisp words. The wall eats the high notes first. The sky does the same thing to thunder. Distance is the wall. By the time the sound reaches you, only the low, gentle frequencies survive. That's why distant thunder sounds warmer. Not weaker energy, but filtered energy. The harsh edges have been quietly worn away. And there's one more sculptor at work. The sound doesn't travel in a straight line. Air near the ground is often a different temperature than air higher up. Sound bends toward cooler air. On a warm evening, the ground is warm and the sky above is cool, so distant thunder bends upward, away from your ears. Some of it never reaches you at all. The sound that does arrive has bounced off clouds, off hills, off the ground itself. Each echo arrives a fraction of a second apart. They blur together into that endless rolling drum. So here's the core of it. A close crack is one clean arrival of raw sound. A distant rumble is the same explosion stretched by the length of the bolt, softened by the air, and blurred by echoes. Most people assume distant thunder is just quieter, as if someone turned down a dial. That's the mistake. The volume isn't simply lower. The sound has been reshaped. The sharp click is still there at the source. You just can't hear it anymore because the air removed it before it reached you. What's left is only the deep skeleton of the sound. This is also why you can guess a storm's distance. Count the seconds between the flash and the thunder. Light reaches you almost instantly. Sound crawls about 1 kilometer every 3 seconds. A 1-second gap means the strike was near, and you'll hear crack. A 15-second gap means it was 5 kilometers off, and you'll hear only a rumble. Your ears already know the physics, even if you've never named it. Storm chasers and pilots use this. The character of thunder tells them not just where a storm is, but roughly how the air is layered between them and it. And on a quiet night, this is why a far-off storm can feel so soothing. The threatening crack has been sanded down into a low lullaby, carried gently across the miles to your window. So the next time thunder rolls softly in the distance, remember what you're really hearing. A bolt hotter than the sun, its violence unraveled by kilometers of air, its sharp voice smoothed into something almost tender. What still puzzles scientists is exactly how the branching shape of each bolt sculpts its own signature sound. No two rumbles are ever quite the same. If you love falling asleep to little mysteries like this,